we actually went through 3 example problems yesterday. So number 1 is like example 1 from chapter 6.5. Number 2 is like example 2, and number 3 is like example 3. So 3 different sets of directions and types of problems with properties of logs. So in the first type, they give you a math fact, an approximate decimal for a log, and you have to try to figure out how to rewrite your problem using the number and the math fact. So in this case, since you're given 5 and you're working with 25, let's rewrite 25 as 5 squared. And then the power property was the third property written down yesterday for Bell, where it means that this is like an exponent raised to an exponent, because logarithms are exponents. Oh, thanks. So the power property of exponents, when you have a power raised to another power, you can actually, you multiply those exponents. So we're going to do that here as well. We can take this exponent down, and it looks like a coefficient, or it gets multiplied to the front. So this is like log 3, log base 3 of 5 doubled. So now I'm going to replace what I have here with the decimal. And then I'm going to use a calculator. And you get 2.93. So this means if everything we've done is true and accurate, this means that 3 raised to the 2.93 is approximately 25. So you can check your answer on this one. We were supposed to be finding what power of 3 results in 25. And this is the answer we got. So you can check it in a calculator, do 3 to the 2.93 and see if you get 25 out. So the answer is 2.93. 3 to the third is 27, so it's very close to 27. Next, for expand. Recall that this is ln log natural. Maybe we should say log natural instead of natural log. Natural log, the L goes first, which is the same as log base E. Euler's E, used for compounding continuously, continuous growth or continuous decay. Euler's. Yeah. It's Euhler. So I like to pronounce it Euler because that's how it looks to me. But the correct pronunciation is Euler. I feel like it's German. You can look it up. Is it German? No. Anyway. It's called the natural log because base E is that number found in nature for continuous growth or decay. So that's called the natural log. I was talking to some ACE Math 2 students, and they said they use logarithms in natural logs and E's constantly, just like a lot. So really justifies the time we're spending in here getting comfortable with the properties. Anyway, when you have to expand, recall that you should write the log more than once. So when I go to expand, the first thing I know is that the quotient property of exponent says when you have a power with the same base top and bottom, you subtract those exponents. Well, this is a quotient. We're going to utilize quotient property, and we're going to subtract natural logs here. We're going to undo it, take it apart, write it horizontally, and convert it to subtraction. When you change the operation from division to subtraction, you have to write the natural log or the log again. So every time you expand, you're putting one more log into the expression. So now I know this is multiplication here, so I can expand that into addition. And then to be fully expanded, we want to take the exponent and use the power property and write it as the coefficient just of that one little portion there. And now that's expanded. Sometimes when you expand, you have the opportunity to simplify. And that's why we do it. Number 3, condense. So expanding means you're going to write the log out more than once. Condense means you're going to try to smush it down into one log. So here we have 3. We're going to try to smush it down into just one log using the property. Okay, what would I do first? I guess first, we got log 6, 4 times log 3 plus log 3. I think I meant to make that last one minus. I would put the 4 as a power. So you do that. When you're expanding, you do it last. When you're condensing, you do it first. And then I'm going to rewrite this as 6 times 3 to the 4th times 3. Which is 6 times 3 to the 5th. It's a pretty big number. You guys get your calculators ready? 6 times 3 to the 5th. So it's log 1458. So that means what power of 10 is 1458? Because this problem had an invisible 10 all the way through it. When there isn't a base there, it's the invisible 10. Questions on 1, 2, or 3? Okay. 2 properties that are helpful in your assignment yesterday and today are here. Before we go on, I want you to write these down. These useful log facts. If anybody wants to turn in the assignment from yesterday on paper, it's due right now. So if you did not get it submitted online, turn it in right now on paper. Name, date, and period. Okay, the graph. Thanks. Okay, so here, log base 7 of 1, anytime the argument is 1, the log is 0. This is going to be helpful with your expanding. So anytime there's a 1 here, the concept is the base to what exponent would result in 1? And the answer is always 0. So there's 2 problems in this section that left you with a 1 and they didn't give a decimal for it. That's because it's implied when the argument is 1, that log is 0. Please write this down. Keith, Annalise, you're going to want to know that. It's not written anywhere. It's not said anywhere. So if you don't get it now, I don't know when you're going to get it. Anytime the argument is 1, that log is 0. Because anything to the 0 power is 1. So you're just going to replace that log with 0 every time you see that. And this is another one. The computer's probably right in front of it. This one showed up in yesterday's assignment as well. And I felt like, boy, I really should have emphasized this a little more. So here I am doing it. This is log 10. Keep in mind there's an invisible 10 here. Anytime the base and the argument match, that log is equal to 1. Because you're saying, well, what power of 10 results in 10? 1. And this doesn't have to be a 10. This could be a 4 and a 4, or an 8 and an 8. Anytime the base and the argument match, that must have been a power of 1. So the answer is 1. So these are two facts to move forward with. A 1 in this spot means the entire thing is 0. Matching base in an argument means the entire thing is 1. These are properties of logs. And so when we go to expanding, you have to simplify them this way or you won't have them completely right. And then I have 2 more for you, and then I'll take questions on the odds yesterday, and then we're going to start the evens today. So this is bell work continued. Couldn't fit it on that slide, but here's 2 more questions for us to do together. Just consider it classwork or notes, but keep it on your bell work paper. When you're ready. Yeah. Someone wrote a note for you guys. Don't take ACE math advice. Just kidding. It's not that bad. I didn't. I would never say ain't. It says it ain't that bad. So proof I would never write that. Just kidding. Not that bad. It does kind of look like my handwriting. Just kidding. It's not that bad. Yeah. I'm going to make a note on it and give it back. And then I'm going to have it back. But. All right. So same fact from number 1. Log base 3 of 5 is approximately 1.456. This means, keep in mind you understand what your log is. This means 3 to the 1.465 is approximately 5, okay? Base, exponent, result, right? Logarithms are exponents. So anyway, you're asked to find log base 3 of 1/5. So first I would expand this using subtraction. So that would be log base 3 of 1 minus log base 3 of 5. You had a problem like this yesterday. You have another problem like it today. And so a lot of students were trying to type this into Big Ideas Math and it was coming out wrong. It's because I hadn't gone over this well enough with you. Anytime the argument is 1, that logarithm 0. So we're going to put a 0 here. And then we're going to replace this with the fact and the directions. It's 1.465. So that's negative. And there's your answer. Yes. Mm-hmm. Keith, what are you doing on there? What are you doing? What would you do to expand number 5, Keith? How would you separate it? With what sign? No. Fractions are minus. This one's a plus. All right. Another thing that we got into yesterday during the assignment is that we're not going to leave radicals in our logs. We're going to look at that instead as the rational exponent form. So that would be log 10 plus log x to the 1/2. So a square root is exactly like power of 1/2. Then we're going to use the power property and put that 1/2 as a coefficient. And then I'm tempted to leave it here, but actually log 10 is the equivalent of 1, because what it is really saying, since there's an invisible base 10, that's the common log, it's really saying 10 to what power is 10, and that's a solid 1. So this whole thing just equals 1. So we're going to move forward with a 1 here, and the answer would be 1 plus 1/2 log x. So 5 examples from the work yesterday. Now I'll take questions on the odds. If you have any questions about the odds, let's do it. It was 1 through 27 odd. Any that you couldn't figure out, of course you had the answer, but you have no idea how to get to that answer. Page complex detected, I don't like it. I had some questions about 27, 23, maybe 19, maybe 17. I had a question about 17. Anybody? All right, well, you guys have all of class to work on these evens. So I want to just give you time in class to work together and to ask me questions. So it's 2 through 28 even. I'll open up the online bit in about 10 minutes. I want you for 10 full minutes working on paper. And you need your paper back. And this is the graph. So very good. There you go. Here you go. Yeah. Let's look at number 2. Okay, so if we use the power property and we put this back up into the exponent spot, this can be rewritten as log base 3 of 6 squared, which means this is the equivalent of log base 3, 36, which means it matches with letter D. So numbers in front are exponents, and exponents can be written as numbers in front, equivalent. So this is the exactly equivalent to this one. Now number 4. So when adding, as long as we have the same base here, we can condense it into 1 log. And we multiply, when you condense it, you multiply these arguments. So this would be log base 3 of 12 which is letter C.